Hi, Assalamualaikum. For today's video, we are going to present about determination of vanillin in vanilla essential oil by High-Performance Liquid Chromatography, HPLC, for case study CHM 260. First of all, I would like to introduce my group members.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Aina Dato Balkis binti Roslan, and today I will present about the lab of determination of vanillin in vanilla essential oils by high-performance liquid chromatography in chapter 6. First and foremost, I will describe to all of you about the introduction. Liquid chromatography is a separation technique in which the mobile phase is a liquid in which sample ions or molecules are dissolved. It runs on either a pillar or a plate. The sample to which the liquid move passes through a column or pan filled with a stationary phase consisting of irregular or spherical particles. Different solutes interact with the stationary phase to varying degrees due to ion exchange, absorption, distribution, or size differences. Therefore, these differences can be used to achieve compound separation and solute column transit times. Next is vanillin. Vanillin is an interesting compound often used in educational chemistry. It is synthesized from the plant's extract eugenol and can be used in the production of various products. Vanillin, on the other hand, is very easy to analyze but less attention to paid to the measurement of vanillin. This time, vanillin is measured with commercial vanilla essence without pre-treatment using RP-HPLC and CE equipment. As the results of several students showing the accuracy of the RP-HPLC and CE separation techniques are shown. The objective of the experiment are: the objective of this work is to analyze vanillin in vanilla extract by HPLC method. The second is a further objective is to compare the accuracy of the HPLC and spectrophotometric methods in the determination of the vanillin content.
My name is Siti Nur Atik Fatimah binti Muhammad Karibi, and I am going to present about methodology. I will start with sample preparation. In this experiment, 3 methods were used to cure 1.5 kg of vanilla samples from Kemiling, South Lampung, which are 30 seconds of scorching in hot water at 65 degrees, labeled as X1. Second, 48 hours of drying in a 60-degree oven, labeled as X2. Then, sun drying for 20 days and 2 to 3 hours each day, labeled as X3. Because of pure vanilla was fermented and dried in the wind, the water content in the pure vanilla dropping from 55 to 65% to 25 to 30%. These are the signs that vanilla had dried. Vanilla color was super black or brownish black and shine. Water contained around 30% of vanilla, thus it was deflected. Vanilla has a distinct aroma and flavor. The last of pure vanilla was kept for at least 2 months. Let's moving on to the procedures for extraction. Pre-extraction Z1s, pure vanilla was extracted in the solution extraction apparatus for 60 hours with 200 ml of 99.9% of ethanol. After that, transfer into a 250 ml volumetric flask. Rinse the extraction apparatus flask with small amount of 99.9% of ethanol several times. Then pour the washings into the volumetric flask. Mix in with the ethanol until mixed up to the mark. In the percolation equipment, extract the pure vanilla from pre-extraction Z2 Erlenmeyers. Submerge Z2 into Erlenmeyer 100 ml for 1 night with around 35 ml of 99% of ethanol. Then, through a paper filter, transfer to a 100 ml volumetric flask and rinse the filter paper with 5 ml of 99.9% ethanol before storing it for use in the second filtering. The result of the cured vanilla from the first submerge was pounded in the mortar, then submerged again in the Erlenmeyer for one night with about 35 ml of 99% of ethanol. Following a one-night submerge, the ethanol from the second submerge was fused with the ethanol from the first submerge using a paper filter like the one used for the first filtering. Pour the washings into a volumetric flask after rinsing the cured vanilla with 99.9% of ethanol, and mix well, mix up to the mark with the ethanol. Next is High-Performance Liquid Chromatography HPLC for UV spectrophotometry. Vanillin was separated on a reverse phase C18 column with methanol acidified water and detected at 280 nanometer, which HPLC has a flow rate about 4 ml per minute. Then, for preparation of standard solution, in 99.9% of ethanol, standard solutions containing 0.5, 1.0, 2.0, 3.0, and 4.0 ppm of each standard were prepared for HPLC. The solutions were kept at -0 degrees Celsius until they were needed for testing. Spectrophotometric standard solution containing 1.0, 2.0, 3.0, 4.0, and 5.0 ppm of each standard were prepared in 99.9% of ethanol.
Next is the data and discussion. As you can see in the table 1, the linear regression equations and correlation coefficient of the vanillin standard as determined by the HPLC techniques and the ISO spectrophotometry assay method. As you can see, the result of the technique and HPLC spectrophotometric intercept A, slope B, and correlation coefficient as we can see above. On the other hand, in the table 2, vanillin contents from 12 treatments of vanilla samples determined by the HPLC technique and ISO spectrophotometry assay method. Table 2 shows the amount of vanillin for 12 samples determined by the HPLC technique and the ISO spectrophotometry assay method. The data show that for the 12 vanilla samples analyzed, this spectrophotometry assay consistently yielded higher value than the HPLC technique. The possible explanation for this, in this spectrophotometry assay method, vanillin is not pure, that mixed with another substances and absorbed at the same wavelength area. This will cause high absorption. Although HPLC uses detector UV, but the sample goes through C80 column and it is separated before it comes to detector cell. This causes only vanillin which is detected, and this also indicated relative smaller analytical result. However, the accuracy of this method is much better. That's all from me. Thank you.
As a conclusion, because there is perfect contact between the vanillin component in the vanilla sample and the extraction solvent, the pre-extraction treatment for cured vanilla slice about 2.5 cm resulted in a higher vanillin content. The content of vanillin obtained by isolation is higher than that obtained by percolation extraction. This happened because of the isolation extraction's continuous solvent purification process. As a result, vanilla extract has a high density of vanillin concentration. Because vanillin was separated from other components in the HPLC method, this proved that HPLC method is an accurate way to determine the vanillin content of vanilla than the ISO spectrophotometric assay. Thank you for watching.